Okay, I'm going back to my share screen, and here was another teaching idea. And the other teaching idea is brain gym. Now, you've just gone out and had some exercise, I hope. I hope you didn't just sit there. I hope that you actually did something. But here's something really rather silly. Some people think it's silly, but I don't think it is. I like it quite a lot. And how it works is this. It is, I will leave this one. I will show you what it is very quickly. Oh, it's not picking up. Hang on. Oh, no, hang on. Just a minute. That's a nice sound, isn't it? It sounds as you can probably hear a silly noise in the background. It is something quite annoying, which I can't stop at the moment. Aha, stopped. Okay. Just a moment. I'll be back in just a moment. Okay. I'll tell you how it goes. Brain Gym. When you get the presentation in, there is a hyperlink. You press it. It gives you the idea. Brain Gym goes like this. Instead of you just sitting there and getting bored, I do two things with my students. One is gym. So sometimes when they are a little bit short of oxygen, I get them to get up and move around. So I get them to walk around the classroom. I say, number one, your right hand on the floor. Number two, both hands on the floor. Number three, you jump up. We walk around. I say, one, they have to touch the floor. Two, with both hands. Three, they jump up. And I do this just for 2, 3 minutes. And when they sit down, they have got some more oxygen in themselves. And you will notice them start to yawn. And when people are yawning, it's because they have suddenly replenished their blood, which is because when you just sit, it becomes deoxygenated. And so you need to get some more oxygen in, and they start to yawn, which is a sign that they are doing that. But the other thing I do is this brain gym. So that's just gym. And it's very important. In an hour or 2 hour lesson, you need to wake your students up sometimes. This is brain gym. Try it. You will like it. If you came to my last teacher's session, you will know this one already. Okay, so you hold the end of your nose with one hand. Try it, really. I won't watch you. Okay, you can just have a go. So you hold, and with the other hand, you go between here, in here, and you hold your ear here. Okay, and now you swap over. Okay, yeah. Oh, okay. So come on, Kasumu. Come on, let's have a go. Kisumu, you need to have a go. Otherwise, you can't teach your students. And this is actually useful. So again, so we're holding the end of our nose very accurately, and the other one comes through and grabs the other ear. Okay. And now we swap over accurately. You're not allowed to just go, yeah, yeah. Not like this. It must be accurate. Okay. And you get the students to do it. And look, I can do it really fast now because I have been practicing, but I bet you can't. Have a go. Go on, have a go. Go on, have a go. Or, yeah, yeah, not bad. Some of you are quite good. Some of you are bleh. Okay. It's okay. It's all right being rubbish at it. But you practice it before you get to your classes to do it. The reason for doing it is that our brain is about the size of a grapefruit, but it is in two halves. And the connection between the two halves is quite small. And when we do this sort of thing, we engage the two halves of the brain simultaneously and they talk to each other. And the grapefruit gets cleverer. Okay, so every so often, just do it, and your students will like it. They will like, you cannot do it, you cannot do it, and they will think this is funny. and you can practice at home. Okay, you practice at home and you make it look like you, oh yes, this is the first time I ever did it, and you look really brilliant at it, and they are rubbish. It's okay. You go, no, it's easy. Look, you see it. Look. There are other ones like you can do this, and then you say, okay, without touching it, you move your left little finger. Wow, it's quite difficult. And if you touch it, you can move it easy. If you just say left little finger, you have to think, well, that's, oh, yeah. Just get them to try and do it. Okay, so we're going to do some chemistry now. So I'm going to share my screen. Okay, so this is an examination question of, this is an IMDR. Remember, empirical formula, IMDR. And this is I'm not going to do it now because we've seen how to do it. But I was having a little conversation with teacher Gillen from Wamuini, and he teaches chemistry and maths, and we agree that it is very difficult if students do not have adequate arithmetical skills. If they are not good enough at arithmetic, there is a problem. And that problem is made worse in moles. And moles is very difficult. So you may need to teach them some arithmetic. Okay, so there's the answer. I will leave that so you can look at it. And the final thing in moles is something called reacting quantities. And I use something called the 4-box method, which a colleague and I invented some years ago. And we found it really helped students. And it goes like this. So I have a reaction, A and B turns into C and D. And in a question, I am told that I have a certain amount of A, and I want to get to produce the amount of D. Okay, so the question says I start with A and I produce D. I physically draw some boxes. So I draw a small box underneath A, then a big box underneath A, then a small box underneath D, and then a big box underneath D. Into the first small box, I put whatever the question tells me about A. So let's say it says, oh, I have 5 grams of A, or I have 25 cubic centimeters of 0.2 mole per cubic decimeter, whatever. I put it in here. In a big box, the 2 big boxes are for working things out. So these are using the triangles. So I turn the quantity of A into moles of A, and then the moles, I use the ratio of A to D to produce the moles of D, and in the last box, I work out the quantity of D. To start with, all you need to do is to start thinking about the 4 boxes, is drawing the 4 boxes, small box, big box, small box, big box. Arrows, small box to big box, up here with the ratio halfway, and then moles down here, down to the big box down here. In each of the big boxes, we sometimes draw a little triangle just to remind ourselves that is what we're going to do. So here's a question, but I'm going to show you how to do it. I'm going to show you how to do this one, okay? So it says zinc and hydrochloric acid. There's the equation. I start with 1.96 grams of zinc, 100 of hydrochloric acid, work out the excess, total volume of hydrogen. That's the one we did before. But in terms of big box and small box, oh, sorry, that's the same one. My apologies. I was going to show you a different one. Hang on, I'll do it a different way. I'll show you something different. So I'm going to stop sharing there. Excuse me. Oops, no, not that. Okay. I hope yours isn't saying silly things like try new tools and so on. Okay. So let's say I'm going to take a very simple example. Let's hope that I can write on this. So I'm going to start with, let's say, CaCO3. Oh, hello, what's happening there? Something very strange is happening. Hang on. I'll just try and rub that out. My screen is not showing anything at all, but yours is. Why is this not working? Oh, no. Oh, dear, this is not working. My apologies. Hang on. I'll try a different one. Let's try another one. My apologies. Sometimes technology is great and sometimes it isn't. Let's try again. So let's see if we can. Right. Aha. Okay, so I have CaCO3. I'm going to take a very simple example. I'm going to heat it up. I'm going to turn it into calcium oxide, sometimes called quicklime, and carbon dioxide. Now, I've made this a very simple example. And I'm going to start with, let's say, 5 grams of this. And I want to know what volume I have of the carbon dioxide. So I draw my boxes. My boxes are not going to be very good because I'm doing this very freehand on a new tablet, which I'm not used to. But small box, whoa, look at that. That is rubbish. Teacher mark, that is rubbish. I'm leaving a gap. Here's an arrow, small box. That's better. And then big box. They're terrible boxes. My apologies. So in this box here, I'm going to work out moles. Now, I know I'm using the first triangle, so moles equals grams over RFM. Now, if I work it out for calcium carbonate, I mentioned earlier it is one of my favorite chemicals because it has an RFM or RMM of 100. So it's 5 over 100, which equals 0.05. Wow, good arithmetic. So now what I do is in this area here, I put the ratio of the calcium carbonate to the carbon dioxide. So in this case, it's nice and easy. It's 1 to 1, which means that the moles here, remember you can shorten moles to MOL, which is not much of a shortening. That means that the number up here, which is going to be moles, is 0.05 moles here. Well, that's good because that's what the ratio is about. If this had been 2 here, then I would double that number of moles here. Over here, it's asking for the volume. So I'm working in cubic centimeters. So I need then the triangle, which I had for the gases. Okay, the one for the gases, that is cubic centimeters up here, moles down here, and 24,000 cubic centimeters here. Apologies for my handwriting. So cubic centimeters equals the moles times 24 cubic decimeters, or 24. Oh, lordy, what's happening here? 24,000 cubic centimeters. I look like I can't write. Actually, I have quite nice handwriting, but you're going to have to just believe me on that one for today. So that means now that all I have to do is I have to say, okay, 0.05 times 24,000 which I think, if I'm not being really stupid, must be about 1200. So that means, here we are. So I go, oops, no, what is happening? Come on, I want to draw. Right, thank you. 0.05 times 24,000, and that equals, I hope my mental arithmetic is right, is 1200 cubic centimeters. Now, if I gave you that question, if I gave that question to your students, if I start with 5 grams of calcium carbonate, what volume of carbon dioxide is produced, they will not know where to start. So always start with the equation and then move on using these 4 boxes, and it will become quite simple. I think, I really think that it becomes quite simple. So I'm going to now clear that. And I'm going to give you one that I'd like you just to think about. Okay, see if we can do it. So now I'm going to start with my calcium carbonate, but I'm going to take calcium carbonate. Oh, hello. Good heavens, something weird has happened here. Oh, something very peculiar. Okay. Very, very peculiar. Okay, I'm going to tell you the question. I'm going to start sharing and try and do it again. Let's go with the whiteboard. Come on, whiteboard. Ah, there we are. So hopefully you will be able to see again, and we are going to draw. Okay, this time I'm going to start with sulfuric acid and copper oxide, and I'm going to produce copper sulfate and water because it's an acid and base reaction. And I'm going to start with 25 cubic centimeters of 1 mole per cubic decimeter sulfuric acid. I'm going to have excess copper oxide. And what I want to know is how many grams of copper sulfate there are afterwards. Now, this is my small box here. Then I have my big box, and in my big box, I'm going to work out moles. Okay, so I know this is moles, and I know that the triangle I'm going to use is the solution one. The solution one, if you remember, is moles at the top, concentration, and volume over 1,000 here. Okay, so moles is concentration times volume over 1,000. Then this goes up here to the small box, which is the moles of copper sulfate, and then down to the big box, which is going to work out the mass. And that one will be the the first triangle, which is the moles RFM underground. Okay, and you need some ARs. So we'll take this as 64. I know it's not. We'll take this as 32. There's a reason for this. It'll make it easier. And we'll take oxygen as 16. So just have a go. See if you can see how you would do this. See if you can start to work on that one. And then I'll go through it with you and we'll just see how straightforward these things become. Okay, so you've got the first bit here, and we work out the moles of sulfuric acid. Then we use the ratio of sulfuric acid to copper sulfate, work out the moles here, and in this bottom triangle, we're working out the grams of copper sulfate. Okay. So I'll start doing it as maybe you are having a go. So I know that my moles equals concentration times volume over 1,000. That equals 1 times 25 over 1,000. That equals 0.025 moles. My ratio is H2SO4. There's no number 1 here. There's no number there, so it's 1. Oh, come on. Oh, don't do that. Don't do that. Ooh, blimey, what is happening there? Sorry. So you have 0.025. That's going to be 1 to 1. So we're going to get 0.025. I'm sorry, my whiteboard has disappeared. Ah, now it's come back. Good. Only it's now not allowing me to draw in it, which is very peculiar. So in this box here, I have 0.025. And then down here, I will have 0.025. It's because I want the grams. So it's moles times RFM. So 0.025 times the RFM or RMM of copper sulfate, which will be 64 and 32 and 64 again, 4 16s, which is 160. And if I'm not very much mistaken, 0.025 times 160 will be 4. So the answer will be 4 grams. Now, because of that, if you can teach your students to do that, it will make a lot of difference to them. The 4 boxes, there are a couple of examples in this presentation. In this, there are quite a number of examples where you can go through things, but this is another teaching idea, and that is, if you're doing moles, know when your audience has had enough and stop. And so I'm going to stop doing moles now. Does anybody have any brief questions about moles just as I get ready for the next part of this? Has anybody got any questions about moles? If you have any longer questions, hang on to them until after lunch, because we'll be doing them at lunch. That's pretty easy. We can definitely do that. But now, if not, I'm going to do something different. Oh, something strange happening here. I can't